Hi, welcome back. The problem today is about the radical equation. Of course, that's radical equation again, but the solution today is slightly different with the other I did in previous videos. Now, let's get started. First of all, you have to rewrite the equation that 2 multiplied by square root of x squared plus x plus 1 equal to 2 times square root of x squared minus x minus plus 1 plus 1. So, first of all, you have to find the domain of x. In this problem, they have the two expressions under square root, that is x plus 1, x squared plus x plus 1. We have to prove that. We have to find the domain of x is to match this expression is always greater or equal than 0. And the same for this expression x squared minus x plus 1. However, we have x. This expression will equal to x plus 1 over 2 square plus 3 over 4. So this is a power of 2 and plus a positive number that's of course always greater than 0. Similarly, for the below expression, we have x minus 1 over 2 square plus 3 over 4 greater than 0 as well. So it means with any x value belong to the real number, its member of real number, it will match to this expression greater or greater than 0. So the domain of x is real numbers. Then the next thing is we with this kind of equation, we usually think about a solution to put the substitute variable. You think we can put it is a. You imagine that you put it become a and put this become b, and rewrite the equation. You have 2a equal to b plus 1. However, in this problem, it's quite different with the others. When you square a and it's equal to x squared plus x plus 1, and b squared equal to x squared minus x plus 1. So we cannot have the relationship between a squared and b squared to make it become dependency with x. For example, if a squared minus b squared is remaining 2x, it cannot be a specific value, something like 0, 1, 2, or 3. Cannot. Even you a squared plus b squared is still equal to the 2x squared plus 2. We cannot. So remember that the purpose of the substitution method, you put the substitution variable, put it like this, and convert it into the system equation. Then you have to find another equation that have the relationship between the substitutions and dependent with the variable, in this case it is x, but you cannot do it in this problem, so we have to try another way. So we don't do this approach. Let's try another thing. So rewrite the equation again. And think about it. How about you square both sides of the equation? Why we do that? Because if you square both sides of the equation, you can remove the value x squared. We have the same number here. We can remove x squared. Then remaining the other is the x only, that is the value with the power equal 1, and the other expression on the right side is the square root of the expression contain the maximum power is 2, that could be converted into the quadratic equation. Now let's do it. So this will be 4 x squared plus x plus 1 equal to 4 x squared minus x plus 1 plus 4 square root of x squared minus x plus 1 plus 1. So then we remove this, and this, move it to here, right to the left. We have 8x, move it on the left too. So 8x minus 1 equal to 4 square root of x squared minus x plus 1. So now you see that's really simple, and you can turn about the solution when you convert it into the quadratic equation. To convert it into the quadratic equation, you just simplify square both sides of this equation, equation 1. But before to do that, you have to limit the domain of x in this case. You see on the right side is the expression contains square root. It means it have to be greater or equal than 0. Then the left side also have the same thing. Then it have to be greater or equal than 0. Then in this case, the condition of xe is x is greater or equal than 1 over 8. So equation 1 square is mean x minus 1 square equal to 16 x square minus x plus 1 then implies to 64x squared minus 16x plus 1 equal to 16x squared minus 16x plus 16. And simplify that, we have 48x squared equal to 15. Finally, we have x squared equal to 5 over 16. So then you have x equal to square root of 5 over 4 or x equal to negative square root of 5 over 4. However, to satisfy this condition, only one value can be received here. This is square root of 5 over 4. So this is the root of the equation we need to find. Square root of 5 over 4. So the lesson of this problem is none of the radical equation you can following by the method to put the substitution variable by this way. You can see in this case you cannot do like this way. And another important thing is once you do the transformation during your solution, you have to check the x condition. For example, I have to check x condition in this case in the equation 1. If not, you might receive a few wrong wrong solution. If you don't have that condition, you might receive this solution as well. So I think this will help you for your math problem, your examination. Thanks for watching. See you later. Bye.